Hello everyone, and welcome to Biopedia. Today we will be discussing the accident at Chernobyl. Chernobyl itself is located in the modern country of Ukraine, close to its border with Belarus. The Chernobyl incident is one of only 2 accidents to be level 7 in the International Atomic Energy Agency's scale. The other is the Fukushima disaster in Japan after the earthquake and tsunami in 2011. Contaminated material from Chernobyl even made it as far away as North America. Now, what exactly happened? The Chernobyl accident in April 1986 was the most severe accident in nuclear power's history. In late April of that year, technical staff tried an experiment which went wrong. This set off a series of events that caused the reactor to go haywire. The lid of the reactor was expelled, there was an incomplete meltdown of the core, and radioactive substances were released into the atmosphere. The USSR tried to hush up the disaster. However, they admitted it after Sweden reported there was an unusual spike in radioactive material travelling in on the wind. Up to 49 individuals died when Chernobyl exploded, but thousands of fatalities were predicted due to cancer and sickness caused by radiation. Chernobyl also kick-started international outrage about how dangerous radiation can be. Today, we're going to explore some examples of the biological consequences of the Chernobyl accident itself. The material emitted from Chernobyl was still having an impact decades after the fact. Now, a lot of the radioisotopes emitted, such as iodine-131, decayed or spread out within days. However, some radioisotopes have half-lives which are a lot longer. Half-life refers to the amount of time needed for 50% of any given radioactive substance to decay. For example, plutonium-239 has a half-life of 24 millennia, which gives you some idea of why it's still an issue decades after the fact. The problem here is that radioactive material is known to be a cause of mutations. We do see tangible impacts of the radiation leaked out from Chernobyl. For example, there has been a study on swallows caught in the Chernobyl area, as well as 2 control regions in the form of an uncontaminated region of Ukraine and Milan over in Italy. We see higher partial albinism, or white spots on feathers, in swallows which were from Chernobyl compared to their counterparts in Kiev in Ukraine, and this difference was statistically significant. This trait of partial albinism seems to correspond with a lower probability of surviving for individuals who have it. Between 1991 and 1996, the number of breeding pairs in the area around Chernobyl dropped from 292 to 76. This is pointed out by the authors of the 1997 paper looking at this, as another indicator that the fitness of swallows in the area around Chernobyl is decreasing. The authors concluded their paper by stating that both coding and non-coding locations in the genome had suffered germline mutations due to radiation emitted in 1986. For context, the germline is the set of cells that ultimately produces gametes. This would mean that mutations would also be passed on through gametes to subsequent offspring. On another note, a 2015 meta-analysis looked at 45 papers examining mutation rates in 30 different species, including humans. Radiation was responsible for 44.5% of the variation in the population studied. Plants were impacted more than animals, while the impact on humans was mid-level. The impact did not diminish with time, indicating that the area did not get better, environmentally speaking, over time. Finally, let's transition to talk about humans specifically. Now, in general, humans did not see a large exposure, relatively speaking. However, this is an average, and those who saw the biggest impact among humans were those who were responsible for dealing with the mess in the reactor, called liquidators. A study from 2001 examined the children of individuals who were part of the cleaning operations at Chernobyl. Only families with children born either side of the exposure were used in the study. What this means is that there were 2 groups being examined, those born before or after their parents had become exposed to the radiation. In all cases except one, the fathers were exposed to the radiation, with the exception being a case where both parents were. The study also examined children born to families who were not connected to the cleaning operations as a control. Children born after exposure had a factor of more than 7 times more new bands of DNA show up in gel electrophoresis compared to both sets of controls. This means they had more new bands of DNA compared to both their older siblings and unrelated individuals. So, although I'm sure there's more we could explore about this, we can see tangible impacts from the radiation leaked out from the Chernobyl power plant in 1986. That brings us to the end of today's episode. As always, thank you all for listening. Feel free to get in touch at the show's email address for any questions, comments, or topic suggestions for future episodes. Until next time, have a great week, everyone.